Over the off-season, our team bought a new CNC router. We wanted to use this for rapid prototyping, making more accurate robot parts, and a wide variety of other uh, uses. Uh, so we bought the Shapeoko because it seems like it was the best on the market for the price. And so far, it's been really great for us. One of the robot parts we wanted to make using our CNC was the frame rails for our chassis, or other various pieces that we'll need tubing for with accurate and precise holes. So what we needed to do this on the CNC is a tubing fixture. There was already one on the market from a company called West Coast Products. The problem was it's for a different machine for the Omeo CNC, and their reels don't line up with the Shapeoko. So what we had to do was make our own. The first step in this process was to design what we needed. Fortunately, in the world of FIRST Robotics, a lot of information is put out there for everyone to see. So I was able to take inspiration from the West Coast Products design and modify it to fit our needs. So what I did was I modified where the mounting holes are so they line up with the slots on the Shapeoko, but I pretty much kept the same layout for the fixture holes. The block of aluminum that we needed to make this part was about $140, so I didn't want to go about cutting right into that immediately. So the first step was to cut a test piece out of wood. As you can see here, I didn't quite have the wood lined up right, so there's a little bit of a lip, but this is where we got started. An issue I ran into was that I had the holes too close to the lip, so the collet holder was starting to cut into the the back lip of the wood. So what I had to do was go back and redesign it so that the mounting holes weren't that close to the edge. I also found that I had the bit set too deep in the collet, which was causing the scarring on the surface of the wood here, so I needed to lower the bit a bit more. The next thing I tried was using a drill bit to speed up our process. That way we didn't have to use a contour toolpath for every hole. Long story short, it was really shaky and it just didn't really work out the way I'd hoped. Now the wood cut is done, it's time to light it up and test and see how it fits. So the fixture points seem to work out really well. They gripped onto the tube pretty strong. Um, that went exactly as I hoped. What didn't work out was the mounting holes. What I forgot to accommodate for was where I had to zero the router on the edge of the wood. So what I have to do is go back and make a modification to the CAD design and make it line up better. As you can see here, the holes were at the right spacing from each other, but they just weren't at the right spacing from the end. The next thing I did was cut out a big chunk of the metal on our Bridgeport. It would have taken multiple meetings worth of time to cut this out on the CNC, so I just took a 3/4 end mill and went down to about 1/10 of an inch away from all of our final dimensions. By the way, this piece of aluminum is a 1 inch thick, 4 inch wide bar that we had to cut about a 1/2 inch pocket out of. The next step was doing test cuts on aluminum. We'd never cut aluminum on the CNC before, so we had to kind of play around with the numbers and figure out exactly what we needed. Um, so what I did was I took this little chunk of the aluminum bar that I had cut off and kind of started cutting pockets into it just to see what it did. The first couple cuts went alright, but there was a lot of chatter in them. You could see it in the cut pattern. Kind of made me think that the bit was loose in the router. Well, turns out the bit wasn't loose. Turns out the fixture that holds the router in place wasn't tight, and that was causing all the chatter and bunch of other issues I was having. I made a pretty rookie mistake and kept over tightening the collet to try and hold the bit tighter. And I broke the router when I was trying to loosen it up. Well, I got a new router, made sure it was tight in its fixture, ran some more tests, and they came out good. Now it's finally time to really start cutting metal. Start this pocket from point 0.4, and it's going to run all the way down to 0.499. It'll run a cleanup pass from there. The aluminum still had a light coating of oil on it from when I took out the big chunk from the on the Bridgeport. And for chip evacuation, we just have a Bosch shop vacuum hooked up to the sweepy. Um, and both of those things combined is just making for a really beautiful cut. Once it finished cutting that pocket and doing the cleanup pass, then it starts cutting all the holes for the mounting and for the fixture clamps and all that. And here's the final product from the CNC. I kind of cleaned it up with a Scotch-Brite pad to get rid of all the lines and cleaned out the holes with a countersink bit just to make sure there were no sharp edges on them and nothing sticking up to push the tubing out of the place that we wanted. And here's a clip of the fixture in action, cutting the chassis rails for our 2023 robot. This is a challenging but fun project from start to finish, and I hope this helps anybody out there looking to kind of do their own project or any teams looking to make their own fixture. If you have any questions, don't be afraid to ask. And thanks for watching.